if you do this problem, you'll know why there's 2 tides a day instead of 1. Okay, so this is M1, right? Okay, we'll say that's M1, right? And X1 is 0. This is M2. And X2 is the Earth-Moon distance, right? 3.84 times 10 to the 8th, right? So the center of gravity, the distance from the center of the Earth, right, is equal to 5.97 times 10 to the 24th times 0, right, plus 7.36 times 10 to the 22nd times 3.84 times 10 to the 8th, all divided by 0.97. Wow, it's a busy day here with internal combustion engine. 7.36 times 10 to the 22nd. Ta-da. All right, let's figure this out. Okay, so I'm going to go 7.36 times, 7.36 E22 times 3.84 E8 divided by parentheses 5.97 E24 plus 7.36 E22 right parenthesis. Did I type that incorrectly? It looks like I did. Oh wow, very unhelpfully my calculator says that the answer is 4676418.0 meters, right? So let's see. It doesn't even do commas. Like, really? You can't do commas? You can't do commas? There's JavaScripts on websites that do commas for you. All right. So that is 4.68 times 10 to the 6th meters. Okay. Now, good question, right? That's the end of the problem, right? But you know, the answer to the question of why there are 2 tides. Think about the Earth and the Moon. These are not drawn to scale, right? And think of that, this system, right? This distance here from the center to there is 6.38 times 10 to the 6th meters, right? And so this 4.68 times 10 to the 6th is like there. The center of gravity of that system, if we could balance the Earth-Moon system, is much closer to the surface of the Earth than it is to the center. So there's actually a bulge of water when the Moon's overhead. That's the first high tide, right? Right, because the water is a little closer to the Moon than the Earth is, and so it bulges up. Not quite that high, right? Okay, that's the high tide that happens on the Moon is directly overhead. But think about this system, right? It's spinning around, and so this water here is on the outside of this thing. Since it's not the center of the Earth, we're actually revolving about. This part's farther from the center of rotation than this part, and so there's a bulge there. If I can possibly use the centrifugal word, right? The water is forced to the outside, or rather, it tries to go in a straight line, right? Because the pivot point is so far away. Remember that what the centripetal acceleration is omega squared r. The whole system has the same rotational angular velocity, but this is much farther away from the axis of rotation. So there's a high tide when the Moon's directly overhead, a high tide when it's on the other side of the Earth from us, which is kind of interesting.